That's what you got to figure out. That's all this all is formula usage with numbers and little trickster questions involved with that. Okay? All right. So notice I have one of these crossed off. It's not that it's bad, but for regular purposes, look at how many options I have for theta over 2. How many do you count? Everyone say the number. There's 3 options. Doesn't this one look like it's the most complicated of the 3? And all I'm saying is if I have a choice that I have to use the theta over 2 rule, I'm not going to pick this one. As a matter of fact, people that were in honors last year, you know what this plus minus means? What does that mean? People that were in honors last year, do you remember? It means we have to make a what? Starts with a C? H? Huh? Choice. You have to have some knowledge about what is the answer. Is it positive or negative? So this plus minus implies a choice. So the only reason I go over that is, oh, son of a nutcracker. Hate that symbol, sorry. Comes up every time we do these notes. You have to make a choice. Is it positive or negative? Do you see any plus or minus in front of these two? No, you don't. That's another reason why I would avoid that one as much as possible. Now, I remember in honors, though, when we were doing some identities, sometimes that one popped up on the left. We're not going to go that far. So it does exist. It is if you want to write it down, go ahead. What I'm saying for our purposes, you're probably never going to use that one. You really shouldn't. And then I'm not going to go into, because I don't know why right now, why there are 3 different versions of tangent of a over 2. Has to do probably with our Pythagorean identities again, but we're not going to delve into that. Okay, and then let's just go into, because you had time to write all those down, this question. Now, as you're writing this down, did we already do 15 degrees? Like, isn't there a difference that equals 15 degrees? Yes, right? Right? What minus what equals 15 degrees, everybody? 45 minus 30. You have another one? Think of another one. That was yours, but there's another one, real simple. 60 minus 45. Then we could use that for the difference identities. But what does this say right here? What does that say? Right there. Use a half angle identity for this. All right? So, okay. It's kind of limited how many you can do this for. But follow the directions, especially on a quiz. If I say half angle, you find it. And did you have to have these memorized, by the way? Not ever in my class. If you go to calculus and if you try BC, maybe. And then I'll talk about how I do have these memorized. The tangent ones, a over 2s, I kind of get mixed up. Where's cosine and where's sine? And I never really thought about it as far as, which one is it or how to memorize them. But the cosine I do. Okay, so the first thing is this. I have to use a half angle identity. So I have to use this one. And I am taking the cosine of 15 degrees. So I'm going to use the cosine of a over 2 equals plus minus a root 1. Now this is how I have this memorized. Don't both half angle identities have cosine in the root for both sine and cosine, right? Cosine likes itself. So it's going to put a plus in front of it and be kind to it. I always think of a minus as negative, don't you? Like negative. Negative Nelly. All right, so cosine likes itself. It's 1 plus cosine A. See, this is what you got to trick yourself with. Here's a over 2 in this little thing. A is the argument, like I like to call it. I think that is the correct use of the term, where cosine A is the argument in here. So I just have a question. It's very simple. What divided by 2 equals 15 degrees? 30. So here's what the argument is. The argument's 30. A is 30. So what's going to go in here? What's going to go in there? What's going to go in there? 30. A is 30. So the ability to use a formula and plug in things appropriately is test number 1. And it really isn't that bad. That's what you got to figure out. But stop! Hammer time. Whoa. What should I choose? Plus or minus? Why should I choose plus? Because who's in quadrant 1? What angle measure? Specifically, are we finding the cosine for?
30.
No. 15. You're ultimately finding the cosine of 15 degrees. So your answer should be positive. Okay, and that's why we choose the positive. Ultimately, understand what you're taking the cosine of. 15 degrees, that should be positive because 15 degrees is in quadrant 1. Right? Are you okay? Where's the third one? How are you? Usually, I pick on you guys usually when... All right, sorry. Okay, now, what's the cosine of 30? If you say a half, get out. Go sit out in the weeds. Isn't that rude? Because what's the sine of 30? I told you to memorize this. What's the sine of 30? At this point, you should know that, right? Little judgmental look from Mr. Samulus. So if the sine of 30 is a half, what's the cosine of 30? Root 3 over 2. Now, if you put a cosine in front of this root 3 over 2, I'm marking you wrong. You cosine an angle, what do you get? You cosine an angle, what do you get? A ratio. We're trying to save those that write that math syntax incorrect. Okay, now you know what this is Algebra 2. What's that class? Sorry. This is a Math 3 or Math 2 question. All right? I have a trick for you that's real fast. There are two problems. A, and someone didn't get this. This radical goes all the way down here, so is 2 underneath a radical, yes or no? Yes. So A, you have a radical in the denominator. B, you have a fraction within a fraction. That's another naughty thing for math, leaving that as a final answer. So you got to take care of two things. One way to do this, killing two birds with one stone, is extending the root so that what I'm going to put underneath here is under the root. And what's a perfect square? What can I do to 2 to make it a perfect square? What can I multiply by? Multiply by 2. Hey, then what can I do to get rid of this over 2 up in the top? Multiply by 2. So really what you've multiplied this by is root 2 over root 2. But the way I extended the line, I made it easier to look at. Okay? And now what I can do is go ahead and mingle these two and distribute and multiply. All right? So to write this out, what this ends up equaling root 2 plus root 3. And one thing you can do in math is leave a root over a root. Okay, so a root underneath there is fine. That's kind of weird. Over root 4. This is still underneath the radical. Now you could have done something about this. I just wanted to show this. Everyone tell me what the square root of 4 is now. So the final answer is root 2 plus root 3 over a free 2. And no, you can't cancel that. There's so many bad reasons why. First of all, 6 over 5 equals what? Come on, say it. It's not right, though. You've never heard of the 6 over 5 equals 2 rule? 5 plus 1? Isn't 5 plus 1 equal to 6? Cancel the 5s, and you get 2. Is this right, by the way? No, you never take a part of a binomial and cancel it with 2. And there's another worse reason why we can't do that. This 2 is underneath a what? In a radical. You can't take something that's inside a radical and cancel with something that's outside of the radical. Then I had someone do this. They multiply both top and bottom by 2, and then they tried to cancel this before they what are they doing? They're going in. It's a geometric figure. They're going in what? Circles. Why would they multiply by 2 then try to cancel and actually cancel wrong using the 6 over 5 equals 2 not rule? Because it's bad math. All right, so why do I do all this? Because these are common mistakes that people make all the time. Is this the same as this? Is this the same as root 2 plus a root 3 over 2? Is that true, or yes or no? Heck no! I almost swore there. Almost swore. No. Okay? Can't split that up. That's like this. Now I don't want to keep doing these common rule. That's the answer. This does not do it. You can't do anything more with that. That's it. Okay? All right. All right, then this next one. Ooh, I like this one. I like it a lot. Because ultimately, what's the cosine of 105? What kind of answer should you get? Uh-oh. We don't know our rules well enough, do we? Negative. Who said that? On fire right now. It's like 9 in a row, isn't it? Smiles. Okay, so plus minus, it's negative. Oh, by the way, what divided by 2 equals 105? These are specific angle measures for a reason. 210. Why is 210 special? It's a what, where? What kind of angle? I'll pause the video. We're putting people to sleep on YouTube. We didn't get that online. Let's just get the notes done, right? Negative, because we're taking the cosine of what? Don't say 210. We're taking the cosine of 105. What the heck was that? And then roots. Okay, cosine likes itself. It's 1 plus cosine 210. 210 is the argument that goes in the formula using a math term. So 210 goes in the formula. And then what is the cosine of 210? What is the cosine of 30 in quadrant 3? What did we just say the cosine of 30 was? It's root 3 over 2, but it's in quadrant 3, so it's negative root 3 over 2. And then it's the identical math to simplify. Extend the line. Make this easy on yourself. Kill 2 birds with 1 stone. This gets the little fractions gone. This rationalizes the denominator. So the final answer, because this is exactly what we did in the last one, it's a negative. Oops, stop. Put the root too big. 2 times 2 is 4. What's the square root of 4? 2 free on the bottom. And then here, when you distribute this 2, this becomes 2. And then we could change this plus negative into a minus root 3. So it is a different answer. And then, but it has the similar numbers because we have similar things happening there. So you don't get many unique answers with this. There's not many angles you can, half of an angle measure equals an exact 30, 45, or 60. But why would you do exact? Engineering. I said this last hour real quick. Why are we doing this in these 2 sections? These formulas exist, when you have to do trig and engineering questions, so things fit perfectly. If you're off by micrometers, then things won't work well. That's one example. All right, but precision, preciseness, decimals aren't always the best. Okay, now back up in this thing, I actually circled something that I thought I had this circled. Didn't I have this squared off when I had this presented, yes or no? Or did I erase it? Was that squared off? Did I have that as a square on it? Anyone remember? Well, it's just because it's my favorite one. This one's not so bad. Why do you think I like this one better than this? The denominator is less complicated. When you have a more complicated denominators, then sometimes you have to do more complicated stuff like rationalizing by multiplying by a conjugate. Anyone know that word? Right? Is everyone okay? It's almost done. Don't worry. Okay. Some people look like they're in so much pain right now. You okay? All right. Hey, I have a question. What divided by 2 equals 22.5? And there you go. This is, it's no rocket science how this is all shaken out. There's got to be an angle measure that we know. So there's very limited possibilities to do this. Just play the game. And then play the game of actually doing the formula that they ask. Oh, here we go. What's the sine of 45? That's what's really happening here. I'll plug it in as it has to look. What's the sine of 45? Root 2 over 2. Did you hear your friends in math? What's the cosine of 45? Root 2 over 2. And this is why I would not have chosen this one, but they're making me. Because I have to do 2 things. First, I can't have little fractions. Oh, hey, can I do this? No. Oh, for the love. Okay, I have 2 problems. I have many problems, but let's stick to the math stuff. All right, fraction within a fraction and a radical in the denominator. I'm just going to tell you flat out, don't deal with the radical yet. Deal with the fraction within the fraction. What can I multiply top and bottom by to get rid of the fractions? 2. Bummer. I like your effort, though. Just a 2. What's 2 times root 2? Root 2. Now, what's 2 times this? Don't forget to distribute. You get what? 2. What? Plus root 2. Oh, now I can cancel the root 2's, right? Get out! Good. Not in my class. All right. So what do I have to multiply by? This is why I would not have picked this one. Because now I have to rationalize by multiplying by what? And if I would have been allowed to use the other rule, the one that I circled that I like or squared off, the rationalization would have been a lot easier. So that's why I always like using that one. So if you have a choice, they're not making you do something, do what I say there. Okay, both top and bottom. And then, okay, you do have to distribute. So this is 2 root 2 minus, what's root 2 times root 2? 2. Weird. Over, and then the whole point of picking a conjugate, yes, this makes me angry. Students that don't get this at this point, you're behind. Whole point of the conjugate is 2 times 2 is 4. Root 2 times negative root 2 is negative 2. Why didn't I do the middle term? Because it cancels. That's what a conjugate is. You know, this is one of the magic things of it. Don't have to keep writing it. What's 4 minus 2? Okay, so 2 root 2 minus 2 over 2. Boy, a lot of 2's. And then cancel those 2's like that, right? Get out! Okay, you said no. All right, there's two ways of going about this. You can either divide both of these by 2 because you could split this up into separate fractions. I don't feel like I need this. I am going to teach it, but I'm not going to write it. So what's 2 root 2 over 2? What's 2 root 2 over 2? Root 2 minus what's 2 over 2? That's how you do it. You could use it by factoring. You got to figure this fraction stuff out though. Oh boy, question number 2. Well, let me just, so I only have one example of this, but I really feel like this is all that's necessary. Because it's just a process about what do I have, what are they asking me to do, and then problem solve from there. So number 1, what do I have to do? Well, I have to do this. Okay. So the tangent theta over 2 rule, I have 3 of them. What's my favorite? The one that has the least amount of work? 1, what? Minus what? Cosine. I don't really have these memorized. This one I don't have memorized. I'm going to be honest. Sometimes if I tried to memorize, I might switch those 2 or something. And I might make this plus, so it is tough to memorize. Will you have to have this memorized? No, you'll have a formula sheet. I'll have all 3 of the a over 2 rules, and you pick the one that's easiest for you. Okay, well then look. So that's here, theta over 2. Here's theta. So I need cosine of theta and sine of theta, and here's theta information. This is what I mean about understanding how to just work with these. Knowing what you have, knowing what you need to find, and knowing the bridge between the two. Well, I'm good. By the way, where's theta located? Theta, right here. What quadrant? 3. So draw it real quick. Now this is a question in chapter 2 or 3. One of the 2 or both. So that we're reviewing that stuff. So it shouldn't be a big deal to remember that basic stuff we've already done when it comes to the final. Do you realize it's November 1st? Oof. Isn't that crazy? Hey, what does that make root 7? What side is this? What side is this? Okay, so it's root 7 here, right? Is that right or wrong? I heard someone over here negative. This is why. Why? Because it's a negative over a negative in quadrant 3. So negative 3 is here. I think you know that. And then I'm not writing this down. Not teaching a Pythagorean theorem. What's negative 3 squared? 9. What's negative root 7 squared? What's 9 plus 7? Oh boy, get the calculator out. That's in you'll learn that in calculus. Don't worry about it. What's the square root of 16? 4. Little joke, little shot. Okay, R. Okay, so what's 1 minus cosine? What's cosine theta? This is theta. Hey, I have a question before we answer this. Where does that mean theta over 2 has to reside, if this is true about theta? Where does theta over 2 reside? I'll give you a hint. If theta is between 180 and 270, theta over 2 should be between 90 and... Not 180 necessarily, but what really? What's half of 270? I don't know. Again, you'll learn that in calculus. That's a calculus concept. 9 plus 7? And what's half of 270? Ah! By the way, what quadrant is this part of? Ouch. That's half of quadrant 2. So what should I expect out of this answer? Tangent of a quadrant 2 angle measure. I'm trying to climb into your head just to think a little bit more. What's tangent of a quadrant 2 angle measure? Mr. KG back there, are you okay? Looks like your head's about to go. You all right or no? Okay, 1 minus. What's the cosine of theta? Let's answer that question. He's all by himself over there. What's the sine of theta? The other one's like, I'm not doing anything. Not my job. Good job. Negative root 7 over 4. Now you have two things to worry about. What am I going to do first that's easy? Not cancel out the 4s. It's not the proper way of saying that. Maybe get rid of the 4s by what? Multiply by 4. I wouldn't even worry about trying to add these as... I just destroy the denominator of 4s. I said that really weird. 4 minus a negative is plus 3 over negative root 7. Now this is wild. This is negative 7 over root 7. You should already know how to do this. Negative 7 root 7 over 7, which ultimately ends up being what? No time. Negative root 7. Hey, what kind of number is that? Net. Yeah, that's true, it's irrational, but it's net. Net. Negative, and we said it should be negative because theta over 2 should be in part of quadrant 2. And tangent of a quadrant 2 angle measure is negative. Okay? There you go.